Here's example 11 in our functions of the graphs topic. If you haven't watched the introduction to asymptotes or example 10, please do so, because I'm going to do this quite quickly, assuming that you kind of know the basic idea. One wee interesting thing about this: investigate the vertical asymptotes of the function f of x equals cosec x. We've got some limits here, 0 and 2 pi. You may not have used these brackets and parentheses before, but you might see them if you're doing more math study. The actual bracket, what was the square bracket, would mean you're allowed to take that limit. So you're allowed to use 0. So in other words, we're saying that x needs to be between or equal to 0 and 2 pi. But because we've got this curved bracket or the parentheses, it means that it's only less than. So the nature of the bracket determines whether we can include the upper or lower limit or not. So it's an interesting extra little teaching point. So what we've got a function f of x is equal to cosec x, which hopefully you remember is just 1 over the sine of x. And we've been looking at asymptotes. You can see that there's going to be an asymptote in this graph because there are opportunities for sine x to be 0. And 1 divided by 0, we can't create a y coordinate, so there's going to be an asymptote. There's going to be a few, and it's a repeating one because it's a sinusoidal function. Therefore, we're only taking that window from x is greater or equal to 0 to less than 2 pi. What do? We make that statement that the vertical asymptotes are going to occur when the denominator is equal to 0. In this case, sine x equals 0, and we can solve that fairly easily. But according to your sine curve, it's 0 at when x equals 0, x equals pi, x equals 2 pi, and so on. We could go negative or more positive, but the first few we would think about are these. But of course, our initial condition said that we can't have 2 pi. It's got to be less than 2 pi. So our solutions are, there are two asymptotes in the domain that we've stated, 0 and pi. So we can say that the vertical asymptotes and don't just write r x equals 0, are the lines x equals 0 and x, or equations of vertical asymptotes, x equals 0 and x equals pi. Okay, so that's the first part. We've investigated the fact that there are two asymptotes. So if we want to think about the nature of them, we can think about the nature of the asymptote x equals 0. And we can draw our asymptote. I still haven't fixed that arrow, but I shall do that. Get rid of the arrow. Okay. So we know that one asymptote has the equation x equals 0. We don't know if it's going to tend to negative or positive infinity on either side, so we'll check it. So our function is f of x equals, we can't factorize it, so we're just sticking with the original function, and we want to think about what happens as x tends to a number just below 0 and x tends to a number just above 0. What happens to the y coordinates? Okay, well, we've still got a fraction. The top number, the denominator is always positive. It's always 1, so we can put a plus sign there. And in this case here, sine x, we're looking at a value of the sign of a number just below 0. Well, if you have a look back up at my bad graph, maybe I should have made it look a bit bigger, but up on the right hand side here, we know that just to the left of x equals 0, like negative 0.1, then our value is going to be negative. It's below the x-axis, so we're going to have a negative value there. In other words, a positive divided by a negative overall is going to give me a positive answer. No, it's not. It's going to give me a negative answer. So what we're saying here, the y-coordinate is going to be negative, and it's going to grow larger so that it's tending to negative infinity. So to the left of the line, our curve will be kicking about towards negative infinity, so it's going to be down there. And if we look at it to the right of the line, so x is just over 0, well, again from the graph we can say that just to the right of 0 the y-coordinate is positive. The numerator here is always positive because it's a constant one. It means that our y-coordinate is going to be positive, which tells us that we're going to end up with to the right of the line our positive values of y up there. Okay. And second example, again, if you want to pause it, you can try it yourself and then check if you agree. That we want to check the nature of x equals pi. So we're still using the same function. F of x is 1 over sine x. So as x is a value just below pi we want to investigate, and we want to investigate a value just above pi. We'll introduce another. I really can't emphasize enough the value of little illustrations like this, rather than just trying to somehow look at numbers and figures. Okay, a picture is so much easier to identify, especially if you're going back to think, what did I find out, when you're trying to put things together in a sketch. So do that, please. And we've got x equals pi is the equation of our asymptote, but is it tending towards negative or positive infinity? Let's just quickly check out. Our y term is still positive in the numerator, but this time for a value of just less than pi. If you want to translate it into degrees, just less than 180 degrees, well, from our function we know that there's pi there. Just to the left of pi is going to be above the x-axis. In other words, y is positive, so we can use our knowledge of the graph there. Positive divided by positive is positive infinity, so that means that to the left of the graph is going to be coming up to the top. And if you think about to the right of the graph, when x is just over the value of pi, 181 degrees, well, you can see from the graph it's already dropping down below the x-axis, so the y-coordinate is negative. So positive divided by a negative is negative infinity, which means that it's going to be down at the bottom and it's going to be heading back up. Okay, so we could summarize that by drawing the two asymptotes side by side and getting a better feel for the whole thing. But at the moment, all I'm asking you to do is to identify where the asymptotes occur, what are the equations of the lines of the asymptotes, and what are the natures of them individually. Okay, so hopefully that helps you go ahead and do that.